Let's see how we can use the ordinal analysis concatenated orderings procedure for more complex study designs that involve 3 or more orderings. So if we look at the affective realism data, for example, the researchers were interested in these positive, neutral, and negative image ratings. And they specifically predicted that the positive ratings would be higher than the neutral ratings, which would then be higher than the negative ratings. So we have a nice ordinal prediction there. Positive, greater than neutral, greater than negative. And we can use this analysis to test out that pattern to see how well it fits the data. So we'll do so by moving over the positive, neutral, and negative into the concatenated orderings box. If we wanted to separate the analysis by, let's say, males or females, we can use the separate by option here. But here we're just going to analyze all 45 cases in this study. So we need to go ahead and define the pattern then. And I'm going to magnify this just to make it a little bit bigger so we can see what's going on. And we can see the positive, neutral, and negative here concatenated. And we need to set up the ordinal prediction by setting up positive as, or selecting positive as the highest. So those should be the highest ratings, followed by the neutral, followed by the negative. So this is the expected ordinal pattern for the data across these 3 orderings. Now, just to be clear what we're doing here, I'm actually going to cancel this out. And let's move these back over, and I'm just going to rearrange them and go back and define that pattern. I just double click those, by the way, to get them to move over. And now notice I've just rearranged them, but the prediction is the same, but I just have to select the appropriate box. So here the positive, that should be highest, followed by the neutral, followed by the negative. So there is our ordinal pattern. Again, all I've done is just rearranged the orderings here, but you can see the prediction is exactly the same. So now that we have that set up, we'll select OK to accept it. And we'll go ahead and just take the defaults here for the options, the randomization test, and the output, and we'll select OK to run it. So we're taken to the text output window. I'll scroll up here. Here are the various options that we've chosen, and I'll cover each of these in subsequent videos. Here are the ordering frequency summaries. I'll cover in another video how I've defined the units of observation for the ratings. Here we see the defined pattern. The blue crosses, again, indicate the expected ordinal pattern, so positive, greater than neutral, greater than negative. And here we see there are 45 cases that we're going to be analyzing. And I'll scroll up here, or scroll down rather. So here are the classification results. We get the ordinal relations between pairs of observations classified according to the defined pattern or patterns. We get these classifiable pairs of observations. We're going to skip that for a moment and go to these classifiable complete cases and describe that first. So there are 45 individuals in this study. I'm going to move this over so we can see the data. So what the algorithm is doing here, when it's classifying the complete cases, it's taking that ordinal pattern with all 3 orderings and seeing if the data match. So we look at the first person. The positive rating is 3.17. Then it goes down to 3.10 for that person, for the neutral. So that matches expectation. But then the negative is 3.22, which is higher than neutral and higher than positive. So that doesn't match. So this person then would be counted as an incorrect classification. Then we go to the second person or case, 3.33 down to 3.27 for neutral. So far so good. Down to 2.96 for negative. Great. So those 3 observations match the ordinal pattern. So this person would be correctly classified. So we just go through all 45 cases and tally up how many individuals match the ordinal pattern all the way across. And in this case, it's 11 out of 45. So that gives us our percent correct classification index there of 24.44. Not very impressive. Now what the algorithm also did is classified the pairs of observations, or classified the observations by pairs, we should say. So what's going on there is, let's go with the first person again, 3.17 down to 3.10, that matches. 3.10 down to up to 3.22, that doesn't match. But again, we could also compare positive to negative. The positive value should be greater than the negative value in this prediction, and here it isn't. So for each person, there are 3 possible pairs of comparisons here. And if you take 3 times 45, then you get 135. So if you look at all those possible pairs of comparisons across all 45 individuals and the 3 orderings, you have 135 possible correct classifications. And here, 83 of those were correctly classified. And so that gives us a percent correct classifications index there of 61.48, much better than the 24.44, that's for sure. Now lastly, we can also take a look at the pairwise comparisons. So looking at the orderings, sort of two at a time. And I'm going to just scroll this up a little bit so we can get it kind of the middle of the screen. So again, we see these pairwise ordinal results. And you can see what's going on here. Neutral, less than positive, so that pairwise comparison. 45 individuals. Of those, 26 were correctly classified. That's about 58%. And then we have the neutral, greater than the negative. How did that pairwise comparison hold up across all 45 people? Well, it was 25 out of 45. A little bit worse, 55.56%. And then we have the extremes, if you will, the positive being expected to be greater than the negative, 45 persons there. Now we're up to 32 out of 45. So that's the best PCC we have in the analysis here, 71.11%. So a fairly straightforward analysis here. We're just going through and checking how the observations match the ordinal pattern. We do so in terms of the complete cases. You have to match all the way across the pattern, or we do so in terms of the pairs of observations taken from the pattern, or we do so in terms of comparing pairs of the orderings in the pattern.